Most pore stimulation results are not design failures. They are selection failures. The wrong method was applied to the wrong limitation. And no amount of design can recover from that. So here is the shift. Stop thinking in terms of methods. Start thinking in terms of constraints. Every well has one dominant restriction. Your job is not to improve production. Your job is to remove that restriction. This lesson gives you the filters to identify it. Start at the top. The problem statement is very specific. Production drops, even though flow capacity exists. So the limitation is not the reservoir. It is near the well bore. Now move to the 4 blocks. Do not read them as sequence. Treat them as conditions. All 4 must be satisfied. First block. Permeability. The formation must already be able to flow. If this is false, stop here. Acidizing is eliminated. Second block. Damage location. The restriction must be close to the well bore. Within reach of the treatment. If the damage sits deeper, acid will not contact it. Third block. Fracture presence. If fractures dominate flow, acid will bypass the matrix. So matrix damage remains untreated. In that case, this method is ineffective. Fourth block. Flow limitation type. This is the most important. The problem must be pore blockage. Not low permeability. Not geometry. Only blockage. Now read the slide correctly. These are not descriptions. They are filters. If one fails, the method does not apply. Split the slide into 2 parts. Left side is the mechanism. Right side is the outcome. Do not mix them. Start on the left. Read the sequence. Remove damage. Restore pore space. Improve connectivity. Reduce skin. Increase flow efficiency. This is not theory. This is a chain. If one step fails, everything after it fails. Now go to the small images below. Before acidizing. Blocked pore space. After acidizing. Flow paths are open again. That is what the sequence represents. Now move to the right side. This is the result. First line. Moderate increase in production. Not unlimited. Proportional to skin reduction. Now second. Improved flow efficiency. Same drawdown. Higher rate. Because resistance is reduced. Now third. No major change in reservoir contact. This is critical. The treatment radius is small. So you are not reaching new reservoir. You are only improving access. Now check the plot. Before treatment. Lower curve. After treatment. Higher curve. But both level off. That tells you. You improved delivery. Not resources. So read the slide correctly. Left side tells you what must happen. Right side tells you what you can expect. If your expectation exceeds that, the problem is not the treatment. It is your diagnosis. Focus on the equation first. J_stim over J_damaged. Productivity depends directly on skin. That is the only variable changing here. Now go to the table. Do not read across all rows. Compare extremes. Top row. Severe damage. Skin is 26. PI increases 4.5 times. That tells you immediately. Performance was controlled completely. By near-wellbore damage. Now move 1 step down. Skin 18. Still large gain. Then typical drilling damage. Skin around 5 to 6. Now improvement drops to about 70%. Still important, but no longer dominant. Now go to the bottom. Undamaged well. No skin to remove. Even if you improve the 1 foot region completely. Only 22% increase. This is the key line on the slide. Now read the carbonate line. Same condition, but deeper penetration. 20 feet. Now PI doubles. So what changed? Not the acid. The radius of influence. Now step back. This table is not about acid strength. It is about where the pressure drop exists. If pressure drop is near the well, removal gives large gains. If pressure drop is in the reservoir, near-wellbore improvement does little. So use this slide to decide one thing. Is the well controlled by skin, or by the reservoir? Split the slide clearly. Left side, where it works. Right side, where it stops. Start on the left. First block. Permeable formations. That is the entry condition. If permeability is not there, nothing here applies. Second block. Damage-driven loss. This is important. Production dropped because something changed, not because the rock is poor. That links directly to acidizing. It removes that change. Now third block. Carbonate or compatible sandstone. That line is about reaction. Not all formations respond the same way, so the method only works when the chemistry allows it. Now stop. That completes applicability. Now move to the right side. These are limits. First one. Effect limited to near-wellbore. That means short reach. You are not affecting the reservoir, only the entry zone. Second. Dependent on placement. Acid does not spread evenly, so some zones improve, others may not. Third. Compatibility. Wrong fluid. You create damage instead of removing it. Now connect both sides. Left side tells you when to use it. Right side tells you how far it can go. If your expectation crosses that boundary, the issue is not execution. The method itself is wrong. Look at the center of the slide first. Conditions, action, result. Read it in order. Permeability is 50 millideci. This is already above the threshold, so the formation can deliver flow. Next line. Skin is positive. That confirms restriction near the wellbore. Now the third condition. Damage is located near the well. That makes it reachable. At this point, the decision is already fixed. Move to the action box. Matrix acidizing. Not selected. Derived from the conditions. Now move to the result. Skin is reduced. Permeability near the well is restored. Production increases. These are consistent outcomes from the previous slide. Now look at the detailed block on the left. The same case is quantified. Focus on the production improvement. About 1.3 to 1.5 times. This matches the productivity table, so the example is internally consistent. Now shift attention to the right side. This is not extra information. These are rejection conditions. Each line should stop the decision immediately. First, low permeability. If permeability is below 1 millideci, the method is not valid. Second, skin close to zero. There is nothing to remove, so no gain is expected. Third, mechanical skin. The restriction is not inside the pore system. Acid does not correct geometry. Fourth, reservoir-wide limitation. The problem is not local. The treatment cannot reach it. Now connect both sides. The left side defines when the method applies. The right side defines when it is excluded. If any exclusion is true, the method is not adjusted. It is rejected. Look at the table. Do not read everything. Scan the colors first. Green means continue. Red means stop. Now start from the top row. First question. Permeability. If the answer is no, stop immediately. No discussion. Now second row. Skin must be confirmed, not assumed. If you do not have it, you pause the decision. Now third row. Source of skin. This is critical. If it is not formation damage, stop. Do not continue. Now move below. The rows change. These are not hard stops. They are design warnings. Look at damage reach. If uncertain, you may still proceed, but with caution. Next, fluid compatibility. If wrong, you create damage, so you adjust design, not reject the method. Then placement. If acid cannot reach all zones, you change placement strategy, not the method. Final row. Economics. Even if everything is correct, it must still justify itself. Now step back. Top 3 rows. These are hard filters. Any failure, the method is rejected. Lower rows. These are design controls. They do not stop the method. They shape it. Do not read all boxes. Take them one by one. Start with the first. requires existing permeability. This goes back to slide 2. If the rock cannot flow, acidizing never enters the discussion. Now second, addresses damage, not formation. That connects to slide 3. Only pore blockage is targeted. Nothing else. Now third, limited treatment radius. This connects directly to slide 5. Short reach. Near-wellbore only. Now fourth, most effective in damaged but permeable systems. This is the combination of slides 2, 3, and 4. Flow exists. Damage dominates. That is where value is created. Now last box. Diagnosis before treatment. This connects to slide 7. If you skip the checks, you misapply the method. Now step back. Each box is not new information. Each box points backward. This slide is only confirming. The logic holds together. Across all conditions. Look at the left side first. This is the full lesson map. All sections are visible in one view. You have already moved through each block. Problem, conditions, mechanism, productivity, applications, constraints, cases, checklist, and takeaways. So this is not new information. It is showing the structure as a whole. Now move to the right panel. This is not explanation. It is a compressed reference. Each line maps to a slide you just covered. So this becomes your quick recall. Not for learning. For verification. Now focus on the bottom section. Up next. This is important. The next lesson isolates fracturing decisions. So what you covered here was one branch. Matrix acidizing. The next lesson builds the parallel branch, when the limitation is not near the wellbore, but inside the reservoir. So use this slide correctly. Left side shows the system. Right side stores the logic. And the next lesson extends it.